Okay guys, so we are looking at chapter 2 now. This is section 1 of chapter 2. The only difference between chapter 1 and chapter 2 is in chapter 1 we were doing the absolute values. And what shape were those absolute value graphs? These, yeah. So now we're going to be working with quadratic functions. And what kind of shape do we get with a quadratic function? A U shape, which is a parabola, yeah. So that's what we're going to be looking at, is how to graph those. First of all, we need to understand the vertex. And the vertex of a parabola is going to be the lowest point of a parabola that opens up. So if our parabola opens up like this, then this lowest point right here, that's going to be our vertex. And it opens up if we have just an A value that's positive. But if we have an A value that's negative, then our parabola is going to open down, and there's going to be our vertex. It's going to be the highest. Sorry about that. Let me get this so you can see it. There we go. Okay, so the vertex is going to be the lowest point if it opens up, and it's going to be the highest point if the parabola opens down. All right. Vertex form. If we have a parabola that's written in this form, where it's A and then B parentheses x minus h quantity squared plus k, as long as A doesn't equal 0, because if A is 0, the whole thing disappears, hk is going to be the vertex. Now, so if this is x minus 4, what's the h value? If it's x minus 4, h would be what? 4. But what if I said x plus 5? Then what is the vertex going to be? Negative 5. And if out here, if it says plus 6, what's k? 6. If it says minus k, what's k? Right. Okay, horizontal translations, just like what we did with the absolute values. If x gets replaced with x minus h, then that is going to be a shift to the right h units. If x gets replaced with x plus h, then it's going to go to the left. So if we replace with plus, it goes left, minus, it goes right, just like it did with absolute value. At the end, if we have the plus k, that's up. If we have the minus k, that's down. I want you to get used to using this function notation, though. So that's what we're going to get to in a little bit. All right, graph this function by using transformations from the parent function y equals x squared. Find the info and graph. So let's look at each thing that has changed. We have a negative in front. A negative in front, what is that going to do? Jackson, do you know what a negative in front does to the function? Right. So the first thing we're going to have is a reflection over or in, both work, x-axis. All right. Then we have x got replaced with x minus 3. And Madeline, what's that going to do? Shift us which way? Right 3. Good. So we're going to go to the right 3. And Garrett, what about this plus 4? What's that going to do? Go up 4. Right. So one way to graph this is to make a table of values based off of the parent function. So we're just going to do negative 2, negative 1, 0, 1, 2. We're going to square those, 4, 1, 0, 1, 4. That's what we get if we square each one of those x's. Now we're going to look at each of the transformations. If we reflect over the x-axis, look guys, if I have this point and I reflect it over the x-axis, what changes, x or y? Y, right? Y gets multiplied by negative 1. So we need to multiply each of these y's by negative 1. So we took care of this. The next thing that happens, we have this shift to the right 3. Does that affect the x or the y if we go to the right? X. So we're going to have to add 3 to all of our x's. Okay, took care of that. And then the last thing we have to do is go up 4. So we have to do what? Where's that going to go? With the, yeah, in this other column here. I'm going to have to add 4 to all of these y's. So add 4. Now, the ones that we actually graph are going to be these values and these values. These are our new points, okay? So I'm going to have 1, 0, 2, 3, 3, 4, etc. And these are going to be the points we have. Now, it's often helpful to find the y-intercept too. If I want to find a y-intercept, I'm going to have to do f of 0. So that means let x equal 0. So I'm going to rewrite this whole function, but I'm going to plug in 0 for x. So I'm going to have negative 0 minus 3 squared plus 4. 0 minus 3 is negative 3, squared is 9, but I have to make it negative 9 plus 4. What's that going to make our y-intercept then, you guys? Negative 5. Let's go ahead and jot that down. Our y-intercept is going to be 0, negative 5. And so I'm going to get that point. And if I know if I went over 1 and down 5 from this point, then if I go over 1 the other way and down 5, that's just going to give me another good point that helps me make the graph more accurate. Okay, there we go. Now, you also should find the x-intercepts. On that one, it's very easy to see the x-intercepts. They're just right there and there. But here's the way you find an x-intercept. You have to set y equal to 0. So I would have to put 0 equals negative x minus 3 squared plus 4. This is how I find the x-intercept. I'm going to go ahead and I'm going to take this 4 over. What's it going to become if I take it over there? Negative 4. So now I would have negative 4 equals negative the quantity x minus 3 squared. I am not allowed to distribute that negative because it's getting squared, but I am allowed to divide by it. So I'm going to divide this side by negative 1 and this side by negative 1. Negative 4 divided by negative 1 is positive 4. A negative divided by a negative now gives me a positive here. How do we undo something squared? Take the what? So I take the square root here and the square root here. Anytime I take the square root and I have an equation, I have to put plus or minus. So the square root of 4 is plus or minus 2. And the square root here is just going to be x minus 3. So now I'm going to have to add 3 to this side. So I have to do x minus 3 can be positive 2, or x minus 3 can be negative 2. What's this one give me then, you guys? X equals what? 5. And what's this one give us? 1. Isn't that what the x-intercepts are? 1, 0, and 5, 0? So those were some other points we could have. 1, 0, and 5, 0. The vertex is this highest point right here. We can also see it just by looking right back there, guys. What is it? And the domain? Good. The range has to go low to high. So what's the range going to be? Close. Negative infinity to 4 with the bracket. Now, I want to remind you how you can check this table. You don't have to follow along unless you have it handy. If you do, you can certainly. I'm going to put this function into my calculator. So negative parentheses x minus 3 squared plus 4. I'm going to turn off my stat plots because I'm not working with statistics. And now I'm going to do a zoom 6 to get back to my standard screen. This is the way it looks, but I want to check my table. So I'm going to go to second graph, and I'm going to look at my table. If I want to jump to 1, I do second window to get to my table setup. I want to jump to the number 1. Go back to my table. It's telling me I should have the points 1, 0, 2, 3, 3, 4, 4, 3, and 5, 0. Those are some points. I can also see the y-intercept, 0, -5, right there. So we are correct. All right, guys, I want you to try number 2 now on your own, getting this table all correct. And I'll be doing it up here if you get stuck. questions do you guys have? You might still be working on some things with it, and that's okay. But you should at least have most of the table done. Does yours look pretty close to mine? Anything you need help with? You guys got the x-intercept even? Good. All right. Awesome. Hey guys, the other way you can do this though, if you don't like doing the whole table thing, is just going off the vertex of -3, -8. Normally if I go out one, I go up one, but because of the vertical stretch, if I go out one, I go up half of one. Normally if I go out 2, 2 squared is 4, so I'd go up 4, but because of that vertical stretch of a half, if I go out 2, I go up 2. If I go out 3, what do I normally go up? But now what am I going to go up? 4.5, yep. So you can use that as well. All right, let's go over to the next part. Okay, just a reminder, how do we do a reflection in the x-axis? Well, to make that happen, we want to reflect the whole thing over the x-axis. So we have to multiply our entire function by a negative. And that's going to be that flip over the x-axis. A reflection in the y-axis, only the x gets replaced with a negative x. So that is not going to change it at all, is it? If I reflect this over the x-axis, or sorry, the y-axis, it's really just the same function. So what this is saying is, what does a negative squared turn into? A positive. But I want to show you something else. Let's say I have a function like x minus 3 squared. So this function looks like this. It's going to be a shift to the right 3. But if I now reflect it over the y-axis, I replace x with negative x, and I don't change anything else, watch what happens. See how now that's a reflection over the y-axis. So on that, I'm not allowed just to square that negative like I can if it's just all by itself. So if it's by itself, I can just square it, but we can't otherwise. Okay, remember the horizontal stretches and shrinks. We replace x with ax. If the a is between 0 and 1, that's going to be a horizontal stretch. Tell me a number, Elise. Tell me a number between 0 and 1. Anything? 0.5? Okay, so what would 0.5 result in, guys? A horizontal stretch of what? 2, because 0.5 is 1/2. Okay? A horizontal shrink happens when a is greater than 1. So let's take 3. So that's going to be a horizontal shrink of what? 1/3. It's the reciprocal. Verticals are what we would think. We multiply the whole function. Okay, we're not going to do number 3. You can go back if you need more practice on the chart and stuff, but I think you'll be fine. All right, let's take a look at this one. Here's a function that we're given. This is saying the new function is f of x plus 3. What should that do to this function if we replace the x with x plus 3? Shift us where? Left 3. So I could just take each of those points to the left 3. All I really have to do is find this one. This one is 1, 2, 3. So I'm going to shift that point to the left 3. My next point went out 1 and up 1, so I would just still go out 1 and up 1. And then that other point, it looks like it went out 2 and up 1, 2, 3, 4, so I can do the same thing. Out 2 and up 4. So that would be our new function. All right, try this one. Think of what that's going to do if we have the function and we have minus 2 on it. There's another way to do this is to look at the actual points, like I have the point 2, 0, 3, -1, 4, 0. And now if I want to go down 2, I'm just going to subtract 2 from the y's. and I can just plot those. Okay, easy enough. I think on your worksheet they make you do it with the table. All right, describe the transformation from f of x equals x squared represented by this, and then state the vertex. Think about it. What kind of transformations are we going to have there? Kenzie, tell me one.
A reflection of the f(x).
Good. And that is the first one you should state, really. Liam, you got one? Okay. And we should actually put that one last. Gloriana, you know what that was going to do right there? Good job. And then the last thing they asked us for was the vertex. You guys know what the vertex is? It is 0, 2. No, it would just be 0, 2. I'll show you. All right, so I put the function in just exactly as it's written there. And here's the way it looks. So see that vertex is 0, 2? If you look at the table, also you can see that horizontal shrink of a third. So it's going to actually take it a lot longer to make all that happen. We could make a table and see it better, but. All right, let's do number 6. Guys, this is the hardest one here, 6 and 7. So I'm going to do 6 with you, and then we'll see if you can figure out 7. Write a rule for G, described by the transformation of the graph of f of x equals x squared. Then identify the vertex. We're going to first do a vertical stretch by a factor of 3. Here's our function. If I'm going to do a vertical stretch by a factor of 3, that means I have to do 3 times f of x. So here's my original function. 3 times f of x is going to be 3x squared. I took care of that. The next thing I have to do is a reflection in the y-axis. That means I have to do 3 times f of negative x. To do a reflection in the y-axis, x gets replaced with negative x. Right here's my x. 3 doesn't change. Whenever I'm replacing x, I have to use parentheses, and I put that. Now, can I rename that as something else? What do you guys think? Can I? Okay, some people are saying yes, others no. So here's what I've got at this point. Okay, this is it. What do you think is equivalent to this? Lucas, what do you think is another name for this? Right here. Can I just square that negative x? Do you think, Lucas? Yes. So that would mean that I can just call this 3x squared. Well, let's see. Is this the same thing as 3x squared? Are they the same graph? Yeah, they are, right? That's one way I can check for equivalency, because I'm just doing a negative x times a negative x. Look, guys, negative x times negative x. A negative times a negative is a positive x squared. You're allowed to do that. Okay? All right, so we did that. Now we have to do a translation 4 units left. So that means I have to do 3 times f of negative. Now this x has to get replaced with an x plus 4. That's the notation we have to use. We have to replace the x with an x plus 4 to go 4 units left. Here's my x. The 3 stays the same. The parentheses stays the same. And I make it x plus 4 squared. Now, here's the difficult thing. Some people don't simplify this, and that's okay. Like some people might have left it like that, and then in that next step, they would have to do negative and replace this x with x plus 4. Okay, so they would say that the answer should be g equals 3 times negative parentheses x plus 4 squared. So some people would say this is the answer, and other people would have done that little simplifying first and would say this is the answer. Well, what that means then is that these two are equivalent. And if I put both of these in the calculator, you would see that these are equivalent. Okay? With either one of these, what is the vertex? Anybody know the vertex? 40 or negative 40? Negative 40, right. All right, guys. Let's see if you can do number 7. Anybody think they know? Oriana? Wow, nice job. She's right. Did anyone right here just go ahead and square the 1/3 x? No? Okay, then I'm not even going to go through that. You would technically be allowed to because it's multiplication. If it had been addition or subtraction, you couldn't. But yeah, there's what you should end up getting. In the other class, most people missed it because they forgot to do the another -2 to go down to. Did some of you forget that? Did anybody else get it right? Okay. A couple people. All right, so you might want to look back through what I did and see if you can figure out where your mistake was.